topology. Okay, I have started recording as well. Now see, I have some routers, some switches, and some PC. Let's say this is my topology. Let me connect the devices. Or here I am not going to use, let's say, any device. Let's say this is PC2. This is switch 2. This is my topology. Let's say a router is connected with this switch. This router is also connected with this switch. In CCNA, actually we learn the routing and switching, how routers like take forwarding decision, how router forward the traffic, how to perform routing. These are the concepts of CCNA. In CCNA, your main motive should be the routing. Understand the routing, how router works, how router build the routing table, how router takes forwarding its decision, how we configure the dynamic routing protocols or static routing, any routing protocol, and how routing works like this. Let's say this is my topology. IP address between routers, doesn't matter what IP address you are using between router, guys, but try to use the IP address between router from the router number. Between router 1 and router 2, let me use 12.1.1.0/24 network. This will be my network. Okay, and you also need to configure network between routers like this also, because in real time you will have the network, what network you will run between router 1 and router 2. But here we don't have any choice, we can use anything. So it will be easy to identify the network between routers if I will use the network ID between routers by the router number. Yes or no?
Yes.
So that's why here I am using 12.1.1.0 network, and on router 1 interface, on this interface I will configure IP 12.1.1.1, and on this interface I will configure 12.1.1.2.
Two.
On router 1.1, on router 2.2. Between router 2 and router 3 I will use which network? Can anyone tell me?
Yeah, 13.
23. Router 2 and router 3. 2 is the first router, 3 is the second router. So
Oh,
that's
got
why
it.
I am using 23 network. Getting my point now?
Yes, got it now.
And on router number 2 I will use which IP address? 23.1.1.2.
Dot one.
1, 2, not 1, 2. Router number.
Oh, router number. Okay.
And here I will use
3.
1.3. Very good. 3. This will be my IP configuration on routers, on between routers. And on LAN network, let's say here I am using network 192.168.10.0/24. This is the network of LAN 1. And let's say this is 192.168.20.0/24 is the network in LAN 2. Done, guys. Here let's say
Yes.
IP address is 192.168.10.10 anything, and let's say here IP address is 10.1. Getting my point, guys? How I am
Yes, got it.
configuring the IP address. Here let's say 20.10, and on PC let's say IP address is 20.1.
This is gateway as well, like 192.168.10.10. It's gateway
Yes,
as well.
will be the gateway for PC1.
But is it network ID as well or no?
Network ID is 192.168.10.0.
This is network ID. That was gateway. Okay.
Done. Now I am going to turn on the device. First of all, I will configure IP address on all the device. After that, as you know, by default 10.1 cannot communicate with 10.2, means PC1 cannot communicate with PC2.
Yes.
Let's say this
Yes.
is PC1 and this is
PC2.
PC2. So by default PC1 and PC2 will not communicate with each other, yes or no? Because
Yes.
here we need to perform routing. Here we need to perform routing, yes or
Okay.
no? In the routing
Yes.
table of router 1, by default there will be only two network, 12 network and 192.168.10.0. In the routing table of router 2, there will be two network, 12 network and 23 network. In the routing table of router 3, there will be two network, 23 and 192.168.20.0. Yes or no?
Yes.
Yes.
Let me show this.
A-
Let me.
And this is dynamic routing, right?
No, then I will configure dynamic routing. I am talking about the by default behavior now.
Yes, yes.
Then we need to configure dynamic routing to make communication possible. First of all, let me configure the IP interface F0/0 say no shutdown. And here I am going to define IP address 192.168.10.10. 255.255.255.0 exit interface F1/0 no shut. And on this interface I am going to configure IP 12.1.1.1 255.255.255.0. I have configured IP address on both interface of router 1, so IP interface brief, or you can say screwed unassign. You can see on fast ethernet 0/0 I am running this IP address, on fast ethernet 1/0 I am running this IP address. Done. And if you will check routing table, so IP route, in the routing table you can see there are only two network, 12 and 192.168.10.0. Done. This is R1. Just I have configured the IP address. Now let me configure IP on R2. Interface F0/0 no shut and IP address 12.1.1.2 255.255.255.0. Exit interface F1/0 no shut to this interface also, and here IP address is 23.1.1.2 255.255.0.
255.0.
Can I ping 12.1.1.1 from here? Yes, I can ping
Yes.
12.1.1.1 because this is directly connected. You can see I am getting reply, right? So here also IP address configuration is done. So IP interface brief exclude unassign. See, I've configured the IP address on both interface, working fine. So IP route, in the routing table it have installed two network. Done. Now let me take you to router number 3. Configure T interface F1/0 no shut, and here IP address will be 23.1.1.3 255.255.255.0. Exit interface F0/0 say no shut over here, and IP address is 192.168.20.10 255.255.255.0. So I have configured IP address on all routers. So IP interface brief exclude unassign. Here also you can see the IP configuration. Done, guys, till here?
Yes.
Okay, now I am going to assign IP address on PC as well. PC1 IP address is IP 192.168.10.1/24, and gateway IP address will be 192.168.10.10. Done.
Yes.
Okay, So this PC can ping to their gateway IP address, ping 192.168.10.10. Yes, this PC is able to ping their gateway
Yeah.
IP address. Now I am going to assign IP address to,
Sir, that
yes,
when we assign the IP address to PC, is it required to do the 24 like slash 24, or no? We can put the subnet mask as
you
well.
can put the subnet mask as well.
Okay, thank
Either you can put subnet mask or slash value.
you. Okay.
Okay. On PC number 2 also let me configure one IP address here. That will be IP 192.168.20.1/24 and 192.168.20.10. Done. Now guys, PC1 cannot ping to PC2. If you want to verify, see, ping 192.168.20.1. Why it's not pinging? Because router 1 don't have root available for this network, 192.168.20.0. So in a static routing, manually here on router number 1 you will define one root for 192.168.20.0 network. Yes or no? By running command IP route, after that network 192.168.20.0, then subnet mask 255.255.255.0, and after that exit interface f1/0 and next hop IP address 12.1.1.2. This is how you configure a static routing. Yes or no?
Which one is the exit interface, sir?
Exit interface for 192.168.20.0 network on router number 1 will be this one, f1/0.
If one
Because
slash
if
zero.
router 1 want to forward traffic in this network, so it have
Yeah.
to forward from f1/0.
Okay, sir. I have a question right here. You just use the interface f1/0, then you put the IP address of the f0/0. Why?
f0/0 of router 2. This is the next hop IP address. Who is next hop for router number 1? Who is the next hop? Next hop means neighbor router 12.2. For router number 2,
Yes.
who is next hop? There are two next hop of router 2. One is router 1 and one is router 3. What is the IP address of router 2? 12.1.1.1. What is the IP address of router 3? 23.1.1.3.
Question. So
Yes.
here, if 1/0, I
Okay.
didn't use this one. I just use next hop and the
That
same
will be
next.
also fine.
Okay. Okay. Good.
But you should use both. Exit interface as well and next hop IP address as well.
If I didn't use, then what happened?
Then also it will work, ping will work, we don't have any problem, but router need to check their routing table twice. See,
Okay.
if I am configuring like this and do so IP route, see the routing table, or we can say static. See, in the routing table it have install one network 192.168.20.0, and this network is reachable via 12.1.1.2, and next hop IP or exit interface is fast Ethernet 1/0. Everything is there with the entry. But if I will remove this entry and I will define only what? If I will define, let's say, only next hop IP address, that is 12.1.1.2. And now if you will check routing table, do so IP route static, you can see the entry. This network is reachable via 12.1.1.2. Now router need to check the routing table again. What is the exit interface to forward traffic to 12.1.1.2? So this time router need to check routing table twice, yes or no?
Yes, clear.
Yes.
So if you will define both exit interface as well as next hop IP address, then router need to check routing tables only once to forward traffic. Okay?
Okay. Okay. Got it.
Now I am going to
Clear.
remove this entry as well. So this is the static routing. Now I am going to run one process. Which process? Rip process on router. Router rip. This is the command to enable rip on router. Once you will run this command router rip, this router will allocate some memory for this protocol. Right? But guys, always keep in mind routing protocols work on interface. So we will enable a RIP routing protocol on the interface of router. How? With the help of network command. Here in router RIP we will run network 12.1.1.0. Once I will hit enter, this router will check that this network is running on which interface. So this network is running on which interface? You tell me. This network is running on F1/0. Yes or no?
Yes.
Of router 1. So router 1 will enable RIP routing protocol on this interface. It will start sending one update message from this interface. Getting my point?
Yes.
Once I will hit enter here, it will start sending one message, update message from here. To router 2. Once you enable RIP protocol on any interface, RIP routing protocols start sending one update message from that interface. Okay. If you want to see, so let me capture the link. I can capture the link also. Now you are not able to see any message over here. See, these are the normal messages. We don't have any message of RIP protocol. Okay. And
Yes.
once I will hit enter over here on router number 1 network 12.1.1.0. See, it is sending one message where source IP address is 12.1.1.1 and destination IP address is broadcast. Are you able to see the source
Yes.
IP and destination IP? Source port is 520, destination port is also 520. So this is the port number of RIP protocol. RIP is an application layer protocol which uses UDP. UDP, as you remember, UDP is a transport layer protocol. UDP port number 520. Okay.
Yeah, clear.
And once I will enable a RIP protocol on F1/0, it will start sending update message from their interface. And we need to enable RIP protocol on LAN interface also. So we will run network 192.168.10.0. Now, once I will hit enter, it will check that this network is running on which interface. So this network is running on which interface? On F0/0.
Was 0.
It will start sending update message from this interface also. Now, with the help of network command, actually on router number 1, we have enabled RIP protocol on two interface. Fast Ethernet 1/0 and Fast Ethernet 0/0. We have successfully enabled RIP protocol on both interface of router number 1. Getting my point?
Yes.
This is the command only to enable RIP. Let me enable RIP on router number 2 also. So let me take you to router 2. On router number 2 also I am going to run command router RIP, after that network 12.1.1.0 and network 23.1.1.0. I am enabling RIP on all interface, yes or no, of routers. Here on router number
Yes.
2 I have enabled RIP on both interface with the help of network command. Now I am going to enable RIP on router number 3 also. Router, RIP and network 23.1.1.0 and network 192.168.20.0.
0.
That's it. Now you can see PC can communicate. PC1 can ping to PC2. See how easy it is to configure. Now see PC1. I'm able to ping PC2. Yes or no?
Yes.
Now there is connectivity. That's it. Now if you will verify the routing table of router 1. So IP route. In the routing table you are able to see some entry with this symbol R. Yes or no?
Rep. Yes.
And R stands for
Rep.
RIP. That means in routing table we are able to see that this router have learned one route from RIP protocol. Which network? 192.168.20.0. And this is AD value. What is the AD value, guys? 120.
120.
And this is the metric. Metric is
2.
2. How metric is 2? As you know, RIP calculate metric on the basis of hop count. This network is how many hop away from router number 1?
2.
So 2 hop away. Yes or no?
Yes.
So that's why metric is 2. And next hop IP address is 12.1.1.2. In a static routing, manually you are defining the next hop IP address. But see, in dynamic routing, router itself learning next hop IP address. Getting my point? An interface, on which interface this network is available?
1/0.
Let's use the name.
Getting my point? In the same way, router 2 will learn to network through RIP. So IP, route and RIP. I want to filter the routing table. See, there are two entry with R symbol. 192.168.10.0, and who have advertised this network? 12.1.1.1. So that's why next hop IP address for this network is 12.1.1.1, and next hop IP address for this network is 23.1.1.3. Means router 3 have advertised this network to router 2. Getting my point?
Yeah, here, what's the benefits of AD value 120?
One AD value is, when we will run the other routing protocols as well. Maybe let's say here we have one more router. R1 and R3 is connected with one more router, let's say. Let's say here we have one more path between source and destination. R4 is there, and this router is connected with R4, and router 3 is also connected with R4. Done. Now router 1 have two paths to reach in this network. Yes or no?
Yes.
So it will compare the AD value. And lower AD value is more preferable. Let's say on this path AD value is 200 and here AD value is 120. So 120 is more preferable than 200. Lower value is best.
Got it. Okay, I understand.
Got it. Now we are not using AD value here. We have only single path because in upcoming day you will understand about AD values in details. Don't worry.
Okay.
Okay. Now you have understand the dynamic routing configuration or not? First of all, tell me this.
Yes. Yeah, I understand.
And on
That's-
router
but-
number
but
2, yes.
That's all.
No, we have some more concept as well. But that's all for configuration.
No.
See, the configuration is
Okay.
done.
Oh, that's easy.
Yes, very easy. PCs are able to ping with each other. That means there is connectivity between end-to-end devices. In a static routing, we need to run, command on router 1, router 2, router 3 very carefully. So it is complicated to implement in large network. But it is very easy to implement dynamic routing. Yes or no? Just we
Yes.
need to run few commands on router.
Okay. I have a question. Like, if we are in the company, they
Okay.
ask for please route this routers. We will choose like which routing we have to do it or no. The company will.
Yeah, company will tell you the which routing protocol you should use.
Give. Okay.
And so let's say you are the super network engineer, super admin. So you will decide that which routing protocol will be suitable for the organization. When you will learn all routing protocol, then you will came to know where we need to use RIP routing protocol, where you need to use OSPF or EIGRP. Now you cannot identify which routing protocol is best. But after learning all protocols, you can easily identify which routing protocol is best for my requirement. Everything depends on the requirement, brother.
Yes, got it.
Okay. And if you will check capturing, so see it is sending the update message. Okay. 1 minute, guys. 1 minute. Till then. Okay. So please design this topology.
Okay, he came back.
I don't know what happened. My computer was shut down automatically.
Okay, brother. That topology is your homework. Okay.
Okay, got it.
You need to configure RIP routing protocols like I have configured in this network.
Yes.
Okay.
Yes.
Okay.
On all router, and then you will verify that your PC1 is able to ping PC2 or not.
Okay.
Okay, start
Okay.
recording, sir.
Yeah, I have started. And in upcoming day, instead of connecting one switch and PC over here, simply I can create one loopback over here. Loopback 192.168.20.1. So you can also consider this loopback as your LAN network. Getting my point?
Yes.
Simply, instead of creating one switch over here and one PC over here, I can create one loopback on the router. Loopback is behind the router, right? On router number 3, simply I can say interface F0/0 shutdown. I have done this interface. I'm going to create one loopback interface, loopback 1, and here IP address is 192.168.20.1. 255.255.255.0. Now this loopback will work like LAN network. So IP interface brief exclude unassign. Done. So now we have one loopback. This loopback is like your LAN network, and this interface is now down. Done, brother.
Yes.
Again, PC1 can ping or not?
Sure. Yeah.
PCC, it's working, right? Because now loopback is available, and that loopback is working like a host. Okay,
We have to like configure loopback in router, right?
right, and it will work like a host. So
So
instead of connecting one switch every time and routers, it will be better to configure loopback directly.
so
Because
loop.
in real time, router number 3, let's say router 3 is my edge router. This router, he will have thousands of prefixes or hundred of prefixes. So here we need to connect 100 number of switches, yes or no? That is
Yes.
not possible. So we can configure the loopback interface as a LAN interface. Getting
So,
my point?
yeah. So we have, okay. We have two interface here, right? F1
Yes,
slash 0 and F0 slash 0. So where we
exactly.
configure loopback interface.
This interface is my LAN interface, yes or no?
Yes.
My LAN user is connected over here.
Yes.
So instead of configuring this interface, I can configure, let's say, loopback 1. Here I can create 255 loopback. Let's say 255 loopback I can create over here on this router. Or do you know how many loopback I can create over here if you want to create the loopback? So
So
see, config t interface loopback, after that range. See, I can configure lots of loopback interface on router.
so if you had time, anytime, we don't have any idea about loopback.
Okay,
Me
Yeah,
too.
we
I don't
don't.
know what does it mean.
loopback is
Loopback.
nothing. Just keep in mind for now that loopback is a virtual interface on router.
Okay.
The use of loopback is different. Loopback is used to check the self connectivity, that self device is working fine or not. So for the self testing, it is
Oh,
a tool which is used for self testing. But here, I am telling you, we are using loopback just for the LAN interface,
okay. Loopback is. I mean, loopback is a interface, right?
virtual interface.
Okay.
Yes,
Okay.
virtual
Okay.
interface.
Got it.
So we don't need to create the physical interface, right? Actually in GNS3, what we are doing in real time, we configure router switches like that. I am configuring router switches in GNS3 to practice, yes or no?
Yes.
So in practice, while practicing, it is not possible to connect 10 switches or 100 number of LAN to a router, yes or no? So but we can create 100 number of loopback on router. In real time, you can consider that loopback as LAN network.
So from that loopback interface, we can connect any PC or switches.
No, we cannot connect any PC. See here, if I am going to delete this one, I have deleted. Now still here I have one host.
Uh-huh.
Here still I have one host on router number 3. That is loopback 1. So IP interface brief exclude unassign. See, this is the IP address of host. Yes or no? This was the IP address of host.
Okay, this is by default. We have in router or no?
Yeah, loopback interface is by default available.
Okay.
Just we need to configure it.
Okay.
Okay. So now you can see this is the IP address of directly host machine. 20.1.
Mm-hmm.
So I don't need to connect one switch over here and one PC over here. Over here also I can delete this switch and PC, and simply I can create one loopback. Here my loopback is 192.168.10.1, 10.1, and here my loopback is 192.168.20.1. That's it. Now I don't need to connect switch and routers, switch and PC. This is directly my PC. You can assume this IP address as the IP address of PC, and this IP address is available on loopback interface on router. On router number 1, what I am going to do? Say no interface F0/0. First of all, here I am going to say no IP address and shut down. And I am going to create one loopback interface, loopback 1, and IP address is 192.168.10.1, 255.255.255.0. Getting my point? I've configured the same IP address which host was using to loopback 1 interface. And now you can see show IP interface brief exclude unassign. Loopback 1 have one IP address, yes or no? And if you want to ping from this host, from loopback 1 interface to this loopback interface, you can ping 192.168.20.1, and we can say source is 192.168.10.1. I was pinging directly from the PC, but this time I am pinging from the router, but source is 192.168.10.1. Means my loopback 1 interface, my PC is going to ping this IP address. Getting my point?
Mm-hmm.
And see, it's working. Done?
Yeah. So if you cannot connect any PC from that loopback, then what's the benefits? What's the
Benefit is here I don't need to connect the switch and PC. Otherwise, to configure this IP address to host, I need to connect one host over here. Yes or no? I will define this IP address to host, then I will connect this host to router. Yes or no?
Yes.
If I need, let's say, 2 network over here, so I need to connect one more host over here, one more host over for 3 network.
Mm-hmm.
But if I am creating the loopback, I can run multiple network over here. Let's say this is after that 10.1.1.1 slash 24, 10.1.1.2.1 slash 24. See how many networks are there on router number 1. Router number 1 have 3 LAN. Yes or no now?
Yes.
So here you need to connect 3 number of switches, 3 number of PC.
Okay.
But if you are creating the loopback, so you don't need to connect the multiple switches over here. Yes or no?
Yeah.
So that I am trying to explain that loopback is a feature available on the router. We are not understanding the concept of loopback or the actual use of loopback.
Okay.
We are just using loopback for my LAN network. I'm replacing my switch and PC to the loopback interface. So I have already configured one loopback over here. I am going to create one more loopback, loopback 2, and here I am going to define IP 10.1.1.1, 255.255.255.0. After that interface loopback 3 IP address to 10.1.2.1, 255.255.255.0. I have created 3 number of loopback 1 over here. So IP interface brief exclude unassign. You can see loopback 1, loopback 2, and loopback 3. All loopback have one IP address. So you can consider that router 1 is connected with these 3 LAN network.
Okay. We can use loopback as a LAN network, right? Each loopback is use a LAN one LAN network.
Yes, so LAN 1.
Oh, got
One
it.
LAN.
Got it.
Each loopback represent one LAN network.
Okay.
Because in real time, one router will have more than 100 prefixes.
Yes.
Okay, so it is not possible to connect 100 number of switch.
Yes, yes.
Okay. Now, okay, leave. This is out of my syllabus. Now we are discussing rerouting protocol. Okay. First of all, the question is how to verify the protocol, which routing protocols we are running on router. Okay.
Okay.
Which routing protocol? Because we have multiple routing protocol.
Mm.
Yes or no?
Yes.
So here what we are going to do? We are going to check the which routing protocols we are using on router. Let me maximize it. And to verify the routing protocol, command is show IP protocol. This is the command to check the any routing protocols like EAGR, POS, PF, that which routing protocols you are using on a router. Let's say interviewer is asking you that what is the command to check routing protocols on router. So command is show IP protocol. After running this command, here you can see the output. In output, routing protocol is
Rip.
RIP. After that, these are the part of filtering. We will discuss this later. Right now we have not configured any filtering for outgoing direction, and for incoming traffic. Right? We have not configured any routing filtering over here. After that, it is sending update after every 30 seconds. As I told you that once you will enable RIP protocol on an interface, it will start sending the update message. Yes or no?
Yes.
So
Yes.
RIP routing protocol send update message after every
30 seconds.
30 seconds. After every 30 seconds, it is sending one update message to their neighbor. And next due is 21 seconds. Means after 21 seconds, it is again going to send one update message. This is also not true. See, this is also not good, because why router is sending update message? See guys, router 1 need to share these network information to router 2, to their neighbor, to router number 2, with the help of update message. So it will send one update message. In that update message, it will include these network, all these network. So router 2, when router 2 will receive this update message, it will learn these all network via router number 1. Next hop IP address for these network will be 12.1.1.1. Then why router 1 is sending same update message after 30 seconds again? Yes or no?
Yes.
It is utilizing the bandwidth. Unnecessary it is utilizing the bandwidth, because update is not required after each every 30 seconds. Yes or no? Update is required only once.
Yes.
But we don't have acknowledgement in the RIP protocols. RIP is a not reliable protocol. So when router 1 will send the update message, router 2 will not send any acknowledgement. So router 1 don't have knowledge that router 2 have received my update or not. So it is sending the periodic update. After every 30 seconds, RIP protocols router or RIP router send periodic update after every 30 seconds. Okay?
Yes.
After that, okay, it is sending the update message after 30 seconds, and invalid time is 180 seconds. Means router, neighbor router, let's say router 1 is sending one update message to router 2, and router 2 have received that update message. It will hold that update message for hold on time for 180 seconds. It will hold that update for 130 seconds. See, router 2 have received one update message from router number 1. Update message. Inside the update message, there is one network 192.168.10.0/24. Done. And it will hold it for 180 seconds. So when it will receive the update message, timer will start from 1, then 2, then 3 seconds, 4 seconds, 5 seconds. After that, 30 seconds. After 30 seconds, it will receive one more update. Yes or no?
Yes.
30 seconds, it will receive one more update message, and again its timer will reset to 0 second. If router will not receive the update message after 30 seconds, then it will wait for 180 seconds. 180 seconds. It will wait for 180 seconds, because this is the hold on time. After 180 seconds, it will flush the entry. After 180 seconds, it will declare that this update is invalid. Means this network is invalid. Getting my point?
Yes.
So RIP router send update message after every 30 second, and hold on time is 180 second. That means neighbor router will keep that update for 180 second. Flush time is 240 second, means after 240 second it will flush the entry from their table. Okay. So, and after that we have some version in RIP. We have RIP version 1, RIP version 2. So now we are running which version? Now we are running RIP version 1. Okay. So it can send the update message to RIP version 1 router, and it can receive the update message from any version. After that, the interfaces where you are running the RIP routing protocol. So you are running RIP on fast Ethernet 1/0, and you are running RIP on loopback 1 interface. Yes or no?
Yes.
So here we have information about the interface as well. After that, from this interface, it is sending update of RIP version 1, and it is receiving update of version 1 as well as version 2 from the loopback 1 interface also. After that, automatic summarization is the topic of tomorrow, and by default it is enabled. You can see automatic network summarization is in effect. Getting my point?
Yes.
How many maximum path this routing protocol can support is 4. That means router can install maximum 4 path in their routing table.
What does
And
it,
how many network command you have run?
what does it mean?
Yes,
For
yes.
path.
Let's say between router 1 and router number 3, there are multiple path.
Yeah. One. Two.
Let's say we have 100 path between router 1 and router
Oh, got it.
3. So it can install maximum how many path? 4 path
4 path.
in their routing table.
Got it. Got it.
Because in real time this will be your not network. Your network will be like this. Router 1, let's say router 3, and here we have lots of router like this. And all routers are connected like this, let's say. Now you can imagine how many paths are there between
Hmm.
router 1 and router 3.
A lot.
Yes or no?
Yes.
We have lots of path available. So maximum path that router can install in RIP is 4. Okay.
Yes. So if you connect
Yeah.
router 1 to router 3, we don't use any cable, right? We can do like as a wireless.
Yes.
Okay. If you connect as a wireless, then still we have like 4 path.
Day by day you will understand, how network will look like, right? This is not my real network. Just I am making you understand the small parts now.
Yes.
Later on I will connect everything together.
Okay.
Okay.
Okay. So by running commands through IP protocols, we can identify some more information like automatic summarization is disable maximum path. After that, we are performing routing. You have run network command. How many network command you have run over here? 2. For 12 network and 192.168.10.0 network. After that, AD value. The distance is 120. This is first command to check the routing protocol. Routing troubleshooting command, show IP protocol. After that, you can run command show IP RIP database. In the RIP database, you can see we have some network inside the RIP database. So RIP routing protocols also maintain their database. It is saying the 12 12.0.0.8 auto summarization. Your network is not 12.0.0.8. Your network is 12.1.1.0. Yes or no?
Yes.
But as by default automatic summarization is enabled, router is considering it 12.0.0.0. If I will disable it, say router RIP and no auto summary. I have disabled the auto summarization. Now if you will verify so IP protocol, you can see automatic network summarization is not in effect now.
Hmm.
Getting my point? And now show IP RIP database. In the database, the entry is, you can see 12.1.1.0/24 directly connected on fast ethernet 1/0. After that 23.1.1.0 is reachable via 12.1.1.2. Means router 2 have advertised this network. Router 1 have learned 23 network also. Via which router? Via router number 2. Router 2 have advertised this network to router 1 and router 2 have advertised 12 network to router number 3. Okay. After that 192.168.10.0 auto summary directly connected on loopback 1 interface and 20.0 is reachable via 12.1.1.2. And here we have metric as well. Metric
It's two.
is 2, metric for 23 network is 1, because in topology also you can see 23 network is 1 hop away and 192.168.20.0 network is 2 hop away. Getting my point?
Yes.
In the same way all routers are maintaining this table. And then lastly show IP route rip routing table. In the routing table it have installed both network, this network and this network. Because in the database you can see in the RIP database there are only two indirectly connected network. Yes or no? One is 192.168.20.0 and another one is 23.1.1.0.
So why it show two network with what one is summary and another one is like
Because
23.2
auto summarization is enabled on router number 2 by default.
by default.
On
Okay.
router number 2 also, if I will disable automatic summarization, router RIP and no auto summary, after running this command on router number 1, if you will run command show IP RIP database, now you can
It's still show.
wait for some time.
Mhm.
Let me do one thing. Interface F1/0, I am going to say shutdown and I am going to say no shutdown. You know, by default, by the way, RIP version 1 does not support classless routing. Now there is some difference between classless and classful routing as well, so we need to discuss that also. In next class we will discuss classful and classless, then you will come to know why it is not supporting classless network and what it mean. So IP RIP. Now you can see 23.0.0.0/8, but it should, in RIP version 2 it will install 23.1.1.0. It is automatic summarization. We will understand automatic summarization also later, don't worry.
Okay.
Till now we had discussed the three types of table in RIP. One, so IP protocol. After that, RIP database and RIP routing protocol. In database, first routers will install the indirectly connected prefixes in their database and after that it will install it in the routing table.
Okay.
Getting my point?
Yes.
Yes.
Same thing is, here also you can verify. Same thing is happening. Okay. After that we have some difference in version 1, version 2. So to understand the difference between version 1 and version 2, first you have to understand the classful and classless network. So let me give you one overview of classful was classless. Okay, here what I am going to do, I am going to write one network. 10.1.1.0/24. This is class full network or class less network. Class full means not subnetted. Not subnetted means without subnetting. And class less means subnetted. Okay, so tell me, this is class full network or classless network? This is classless network, guys, because class full network is 10.0.0.0. As you know, this is a IP address of which class? Class A.
Yes.
Yes.
First value is 10, and by default subnet mask for class A is 255.0.0.0. Means there are only 8 network bits: 0.0.0,
Ye-
10.0.0.0/8. This is class full network. Yes or no?
Yes.
And this is classless network, upper one,
Oh, okay.
right? So here if I am writing 10.2.0.0/16, this is classless routing,
Last.
Yes.
classless network, because class full network will be 10.0.0.0
So
slash
you say classful network is not subnetted. If not subnetted,
yes.
that mean classless.
No,
Not
class full.
subnetted means class full. Not subnetted, this is what class full. Here we have not performed subnetting. Yes or no?
Yes.
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 And here we have performed the subnetting in this network.
Oh
Yes.
yeah, got
Yes
it.
or no?
Got it. Got it.
So this is subnetted.
Yes, got it.
And RIP version 1 does not support classless routing. Means subnetting is not possible in
Rep version.
RIP version 1. So let's say router 1 have some network like 10.1.1.0/24, 10.1.2.0/24, and 10.1.3.0/24. How many network router 3 have?
Three.
3 network, right? But RIP version 1 will consider these all network as single network, that will be 10.0.0.0/8, and it will advertise to their neighbor.
Okay. So in this case, like, I have a question. Router one has a four network.
Okay,
One is 12.1.1.0, which is
okay,
connect and interface 1/0, right? And three is
yes,
here. Like we have four network here, right?
right.
Okay.
We have total 4 network, but whenever router 1 will send any routing protocol update from this interface,
Mm-hmm.
it will not include 2L network. It will not include, because it is sending the update message on the same segment. Yes or no? Means it is sending update message to router 2, and router 2 already know about the 2L network. So why router 1 will send 2L network in the update message? It will include these network only in the update
Okay.
message. And as RIP version 1 does not support classless routing, it will advertise one network only. That will be 10.0.0.0. If you want to verify, what I can do, I can configure this loopback on router number 1, and I can advertise it in RIP protocol. Let me configure it. Interface loopback 1. Here I am going to say IP address 10.1.1.1, 255.255.255.0. Done. Interface loopback. Okay, so this IP address is overlapping with loopback 2 interface. So let me take you to loopback 2 interface, and here interface loopback 2, I'm going to say no IP address. Okay, then again interface loopback 1, IP address is this one. After that interface loopback 2, and IP address is 10.1.2.1, 255.255.255.0. It is overlapping with loopback 3. Interface loopback 3, no IP address. Interface loopback 2, interface loopback 3 and IP address is 10.1.3.1 255.255.255.0. Now if you want to verify, you can see do so IP interface brief exclude and assign. Here I have configured the IP address on these three loopback. Done.
Mhm.
Now I need to advertise this network in RIP. Until and unless you will not advertise this network in RIP, router 1 will not share this network information to router 2. Yes or no?
Yes.
Now if you will check the routing table of router 2, so IP route RIP. It is not learning any 10 prefix. Yes or no?
Yes.
So now what I'm going to do, I'm going to advertise this network in RIP. So command router RIP and then network. So through network command, we are advertising prefixes in any routing protocols. So here I'm going to say 10.1.1.0. Again, one more network, that is 10.1.2.0, and one more network, that is 10.1.3.0. So I have advertised these three network in RIP protocols. And now on router number 2, I'm going to check the routing table again. See, router 1 have advertised which network? 10.0.0.0/8. Router 2 have learned this network, not 10.1.1.0, 10.1.2.0, 10.1.3.0. Why? Because RIP version 1 does not support classless routing.
Okay.
So here what I am going to do, I am going to change the version. I'm going to say router RIP and version, not 1, version 2, and no auto summary. I've configured RIP version 2 over here, and router number 1 also I am going to change the version. Say version 2 and no auto summary. Done. And now on router number 2, so IP root RIP. It is still learning which network? 10.0.0.0. Let me do one thing. On interface F0/0, I am going to run command shutdown and no shut again. And so IP route RIP. Now it is learning all individual prefixes. Yes or no?
Yes.
Because RIP version 2 support classless routing, or we can say subnetting. So this is interview question that RIP version 1 does not support subnetting or VLSM, but RIP version 2 support subnetting and VLSM. Okay.
Yes.
Any doubt till here?
No.
No.
So just only one question. Like
Yeah.
you configure in router one loop 10.1.1.1, not I mean that zero. So
But this is the network ID. That is the IP
oh,
address.
you just use interface, right, for that one?
Yes.
Okay, got it.
So when you are configuring running this command interface loopback 1 IP address 10.1.1.1 255.255.255.0, what will be the network ID?
10.1.1.0.
Yes,
Got it. I understand.
10.1.1.0. In a static routing also you are advertising this network,
Okay.
right?
Yes.
Anything else?
That's it.
I have a question. Like, is it possible for you, sir, to show us this routing in the real world?
Yeah, it is possible, and I will show you also.
Okay.
But you know, nowadays we are not using RIP routing protocol.
No,
No
no.
one is using RIP. No one is using RIP routing protocol. But to understand the protocol which we are using, you have to understand RIP. Like we are using OSPF. So you cannot directly understand OSPF.
You got it. When we're done, just one day, just show us like how we do it in the real.
Definitely.
Thank you.
Anything else?